Hey everyone, what's up? Welcome to another episode from Pacific Arc Tig Welding. My name's Dusty. Welcome to the first episode of the start of my series, How to Tig Weld Stainless Steel. This is going to be an intermittent how-to series. I'm going to put one of these episodes out every once in a while, but for today, we're just going to start out with the basics. We're going to start out with the absolute basics of how to TIG weld stainless steel. For everybody that's watching that regularly watches the show, what's up? Welcome. Thank you very much for tuning in today. For everybody that hasn't checked out the show before, welcome. My name's Dusty. I really appreciate you checking out the channel. If you enjoy what you see today, please consider subscribing, like, and most importantly, share what you see today. For anybody that would benefit from this video or anybody that enjoys it, I really appreciate anybody that shares this stuff. I'm really trying to grow my channel, so that kind of stuff really helps me out, so I appreciate it. Thank you. If you're new to the channel, be sure to check out other videos that I've put out. We do a mix of all kinds of TIG welding art, where we do all kinds of crazy TIG welding tricks. We do TIG welding how-tos, mostly aluminum so far. I've got an aluminum TIG welding how-to series I put out about 5 or so months ago. If you guys have watched those already, thank you very much for checking those out. If you haven't, bounce on over and check those out. They're in the description below. I've actually been thinking about redoing those TIG welding ones. I'd like to kind of redo them a little bit differently, go into a little more depth on a few things. So if you have watched them before, if you'd like me to expand on what I went over in those videos a little bit, just leave it in the comments below. I like hearing from you guys. I like knowing what everybody wants to see on this channel, so I really appreciate it. So a little preface for what we're gonna do today with TIG welding stainless steel. We're gonna do something a little bit different from what you might see on most how-to channels. There's a lot of good stuff out there. I've watched a bunch myself just to brush up on some skills and stuff like that. But what we're gonna do today is we are gonna start with the absolute basics. We're gonna start from square one. This is something that a lot of channels don't really take a lot of time to dig into, and I really wanna emphasize that the way that you first learn how to TIG weld stainless steel or how to TIG weld aluminum or anything in general is starting with the absolute basics is very important. What tends to happen is a lot of people get really excited to get going, which I understand because TIG welding is a lot of fun. When you get some cool joints and stuff like that put in front of you, especially pipe welding and stuff like that, it's really fun. So a lot of people are very ambitious to get going on the fun stuff. What happens is not a lot of people tend to stick with the absolute basics. So what we're gonna do today is we're gonna focus on those basics. We're gonna sit on square one and really drill down on how to really get going with TIG welding. You can use this to relate to aluminum TIG welding, but we are gonna be going over stainless steel specifically today. If you're a little more advanced, I definitely encourage you to watch. You may pick up some stuff. I certainly, funny enough, watching some how-to stuff to brush up on kind of my theory. There's a lot of stuff that I realized that was good for me to brush up on. So if anybody that's a little bit further along with TIG welding, I definitely recommend just watching along, just enjoy it. If you already know all this stuff, that's cool. I really appreciate you watching and hanging out with us. Or me, I don't know, I keep saying us, it's just me. So for part one today, we're gonna focus on absolute basics, that's it. And the material we're gonna be working on is just a basic flat plate. There's no butt weld, no joints or anything like that. A lot of stuff I've seen online for basic stuff starts with a joint. So they're giving you a bit of theory, which is good. However, their instructions on how to get going are on a joint right away. And fundamentally, I kind of find that this sets people up for a little bit of frustration right off the bat. When you're tackling a joint or anything like a butt weld or anything like that, it's kind of tricky. I'm not gonna lie. You hear a lot of people say that TIG welding stainless steel is really easy. It's not. I'm sorry. I hate to burst your bubble, but it's not easy. It's very finicky, it's a little bit difficult, and it's very reliant on our setup. So that's what we're gonna go over today. We're gonna go over a lot of setup stuff, and we're gonna just focus on getting a good clean bead and getting our machine to run really well. So let's start off with some super basics. A lot of this stuff I learned when I went back to school from my weld supervisor and stuff like that. But the first thing we're gonna go over is what is stainless steel? So it may seem pretty simple, but basically stainless steel is an alloy of iron steel, basically. What makes stainless steel different than mild steel is that there's an addition of chromium. So anything that contains on average above 12% chromium and above is gonna be considered stainless steel. So what the chromium does is it adds a thin layer of oxide on the surface of our stainless steel, also called the passive layer. What the passive layer does is it prevents corrosion. So that's why you see a lot of like marine stuff, like a lot of boat parts, boat handrails and stuff like that. A lot of handrails and outdoor welding in general is a lot of the time done with stainless steel, specifically for that. So anything that's exposed to weather, especially where I live, we live near the ocean, so a lot of stuff, a lot of boat parts and stuff like that are mostly 100% gonna be stainless steel because corrosion happens super easy with mild steel. Obviously with different types of stainless steel, a lot of stainless steel can contain more and more chromium as well as some other stuff. The more chromium that's contained in stainless steel, there's gonna be more corrosion resistance. So this stuff will be less prone to be oxidized or rusted or basically affected by elements outside and stuff like that. So for the more chromium, there's going to be more corrosion resistance. As well as chromium, there's also other alloys added to stainless steel. For example, you'll see stuff that's listed as it has carbon, silicon, manganese, and there's also going to be additions of nickel and molybdenum. Molybdenum? I don't know how you say it, but I'll put it on screen right there. So as you'll probably be able to see if you look up a little bit about stainless steel, some stainless steel is still prone to corrosion. Basically, this depends on the different additions of alloys and stuff in the stainless steel. Also, it depends on what it's exposed to, etc., etc. So there is stainless steel that will still corrode over time and stuff like that. And under certain circumstances, it'll still corrode. But overall, stainless steel, like I said, it's been used pretty heavily in the marine industry around here. It's used in food industry, medical industry, stuff like that, where it's going to be really dependent that the stuff does not oxidize and it stays really, really clean. So for anybody that's got some steel kicking around their shop, how do you tell if it's stainless steel? Upon first glance, if the stuff's been stored inside, it's gonna be kind of hard to tell if it's stainless steel or mild steel. A pretty easy way that you can check out what you've got is stainless steel is with a magnet. So for example, with stainless steel, because it has a passive layer on it, if you put a magnet on it, it's not going to be magnetic. If you put a magnet on mild steel and stuff like that, the magnet will stick to it because there's no passive layer. However, with some stainless steels, because like we talked about with the different alloying agents and stuff like that, you can have certain combinations of different types of stainless steel. There are some stainless steels that will be slightly magnetic or kind of magnetic. So as a matter of fact, some stainless steels, there's one classification called ferritic stainless steel. I think that has lower than 10% chromium. This will react to a magnet, so it will be magnetic. So you can't always use the magnet trick as a surefire way to tell if it is in fact stainless steel. It's just kind of an easy way to generally tell that what you've got is stainless steel. Most stuff you'll have kicking around your shop, like some scrap, will be like a 304 stainless steel or something like that. These ones are super common, and these ones are the ones that contain more than 12% chromium, so they will not react to a magnet. But like I said, it's not always the easiest way to tell because you may run into some stainless steels where they will react to a magnet. It may trick you and think that you're dealing with a mild steel, but for the most part, for whatever you got kicking around the shop, it won't react to a magnet, so chances are you'll be able to tell fairly easy if it's stainless or not. So what we're gonna start with here right now is the most important part of how to TIG weld stainless steel, our torch setup. A lot of people tend to kind of look at their gear, get it set up, and think it's good enough. That's cool. A lot of people kind of gloss over this part. They basically set up their gear, it seems to be running cool, and then on they go and they try and do some TIG welding. Basically, it's something that not a lot of people take a lot of time to really make sure that they understand exactly how everything should go together and how to get it running really clean right off the bat. So that's what we're gonna do right now. We're gonna go over our torch setup. So as you can see here, we got two different torches here. These are both pretty common torches that you'll find basically with some kind of TIG welding setup. Chances are you're gonna have one of these two different torches. These guys are from CK Worldwide. CK Worldwide is probably one of the most common TIG welding gear companies. They distribute stuff all over the planet. Obviously it's called Worldwide, but they make really, really nice TIG welding stuff. I got this stuff from them a couple weeks ago, and I've really been itching to kind of break it out and give a good demo with it. So if you haven't already, check out CK Worldwide's website. I'll put it on screen right now. Go there, they got all kinds of gear. You'll be able to get set up with good gas lenses, good gas diffusers and stuff like that. Anything that you're gonna need to get a good TIG welding setup going, you're gonna be able to find it on that website. So I definitely recommend you go check it out. So our two different torch setups we got here. This one here is one of the slimmer ones that you can get for TIG welding setup. This is a CK9 style torch. So it's an air-cooled torch, but basically the hardware, so the 9 style hardware will work for a water-cooled torch as well. And the water-cooled version of this torch is the CK20 style torch. This guy over here is a bit of a higher amperage torch, so you can use this. Again, it's gonna be air-cooled when I hook it up to the hose here. This is the CK17 style torch. But you can see here, I basically got a general setup of the different types of collet setups that you can find to weld stainless steel with these torches. So we'll start off with the CK9 style torch, and I'll show you kind of a different setup that you can run with these guys here. The most basic setup I saw for a 9 style torch that I would learn on was something like this. It's like a gas diffuser. So it's basically like a small collet. This collet here is called a split wedge collet because it has like a little split in it. And the difference between the two different types of collets you can get is this one on the right here. This is just a basic wedge collet. So there's no slit in it. It's basically just a wedge style collet. Those are the two different style inner collets that you can use for stainless steel, as well as aluminum, but this is what we're gonna be going over for stainless steel here. So this is the gas diffuser style outer collet body. So the inner collet sleeve will go into the outer collet body like so. It will pinch the tungsten shut. It will pinch the tungsten so that the tungsten will stay at the length you set it for, like so. And then the gas comes out these little gas holes. It comes out the little gas holes there. And that's basically how it works. And then you put a cup on top of it like so. And then the cup will direct your gas out the end like so. And that's basically how you get your gas coverage set up with a pretty basic setup like this guy here. So this is a gas diffuser setup. They work fine. Like I said, this is kind of the stuff that I learned on. It still gives you good gas coverage and stuff like that, but there's no gas screens or extra other things that you have to worry about, especially when you're first learning. You're gonna be dipping, you're gonna be making a little bit of a mess with your tungsten, so get ready for that. Might be easier to start with something like so because it's super simple and you're not gonna damage your gas screens or anything like that by dipping your tungsten and contaminating it. So like I mentioned, this is the gas lens style collet setup for a CK9 style torch. So again, we got the wedge collet, which I really like these guys. They tend to handle heat a lot better over time. With the split collets tend to warp pretty easily over time, obviously because there's a slit in the middle. Each side can heat up a lot faster. They're a little bit thinner, so over time they tend to distort quite a bit, which can cause a little bit of gas problems with the way your torch is running. So I would encourage, if you go onto CK's website, look for the wedge collets. The wedge collets are super nice. They don't tend to distort as much. They take the heat over time a little bit better. So I would prefer to use these pretty much all the time now. Your wedge style collet will go into the outer collet body. Now this guy is a 332 gas lens setup. So as you can see here, this guy I've done a bunch of welding with, and look how clean the gas screen is. So if you're ever setting up and you have a gas screen that looks like something like this, it's just a mess. It's a total mess. You're gonna get gas deflection. Gas is not going to come out in an even spread. So you want something like this here. This guy is gonna be nice and clean. I generally try and clean it as often as I can. What I do is I tend to clean it with a wire brush. I don't pound the wire brush on it and scratch the hell out of it. I just tend to kind of press it to it and turn it slightly. The reason that you don't wanna go too aggressively with a wire brush on your gas screen is you can puncture the screens. If you puncture the screen, it's pretty much garbage. It's not going to run very smoothly at all. You're going to get an uneven gas spread coming out of it. The idea of a gas lens is that the gas comes out in a super smooth gas cover. So if you have any kind of tear or any kind of hole or a bunch of spatter and other kinds of garbage and whatnot stuck to it, it's going to be an uneven gas spread. So you want to keep it nice and clean like this here. But basically what this does is this will go into your torch as well, just like it will with a gas diffuser type setup. And then you can do a couple different types of setup for cups. You can do something like this ceramic cup here. The ceramic cup just screws over top like so, and your tungsten sticks out the end. There's also different type setups. This is one from Michael Furick. So Furick cups, I'll put that on screen right now. Check out that website. That guy's got a lot of amazing stuff. This is a number 12 cup. It's pretty huge, pretty extreme, but it's awesome. So any kind of coping and stuff like that where you're welding around tubing, something like this is really sweet. But same deal, it just screws to your outer collet body. You set your tungsten stick out, etc. And you're off to the races with something like that. Probably one of my favorite ones I've been running lately is this these set of cups from Edge. Edge welding cups, I'll put that on screen as well. These guys make phenomenal stuff. I really like this company. This comes with a little adapter like so. The little adapter goes over it like that, and then the cup slides over these O-rings, and you get a proper gas seal, and that's the way that guy will set up. You get a nice clean arc with any of these setups here, but it's basically how you make sure you put your stuff together that's going to be really important for how you get the proper gas seal. So for the 17 style torch, it's almost the same thing, but it's slightly different. So again, we've got our wedge collet. So the wedge collet is a lot bigger for this because obviously the torch is meant to carry a little bit more amperage, a little bit more heavy duty. You can do some aluminum welding and stuff with this guy here. However, this thing rips for stainless really, really well too. So again, our wedge collet goes into the outer collet body. This is the gas lens type setup again. So we got our screens in there, they're pretty clean, everything looks real good. I might even give that a little bit of a scratch next time I use this one, but today we're going to be using the 9 style torch. But for the sake of showing you today, what you want to do is you want to make sure that this threads in to the torch head. And then what's really, really important is that your back cap is loose and this guy has tightened in all the way. When you tighten it in, you don't need to absolutely clamp it down. You just want to give it a little squeak with your MIG pliers or your welding pliers, whatever you want to call them, so that it's not going to be loose. And this guy is still loose. Basically, what can happen is if this is wound in all the way, when you go to wind your gas, when you go to wind your outer collet body all the way in, it will bonk into the end of this guy that's threaded in too far. Then what will happen is you start welding, this will back off because of the heat expansion will cause your collet to move slightly. And then all of a sudden, all this gear inside will be loose. So you want to make sure that when you put your gas lens, your collet and everything on, that this guy is done up nice and tight while this is still loose. And then you set your tungsten stick out distance and then you tighten this up. That way you've got a good gas seal, everything's put together really well. Put your cup over top and you're ready to rock. Okay, so now that we've been over our torch setup, we're gonna go over a little bit of a gas and machine setup here. So for today, I'm gonna be using 100% argon as our gas shielding. Our argon is pretty typical with stainless steel welding. It gives a nice clean gas cloud, depending on how you set it up as far as your post flow, as well as your working pressure through your regulator. You're gonna tend to be able to keep away all oxidization and keep your weld super clean. So we're just getting started here. So what I'm gonna do is I'm probably gonna set my working pressure through my gas regulator to about 15 or 17 CFH, that's cubic feet per hour. Not cowboys from hell like I used to think. Shout out to all my Pantera fans out there. But again, our range of about 15 to 17 and a half CFH is gonna give you a really good gas coverage. If you tend to have too low of gas coverage, as you move away from a weld area, it's gonna oxidize very quickly. You're not gonna have a lot of gas spread over the area that you're welding in if you're doing a longer, especially around pipe and stuff like that, where you tend to go around a corner or something like that. As you go around corners or you move on with longer welds, if you don't have an adequate gas pressure coming out of your torch, a lot of that is gonna very quickly oxidize behind you. So you'll be running a really nice clean weld. However, as you move your gas coverage away from the stuff that is still really, really hot, it will oxidize following you. So for example, I'll show a couple pictures right now of just some examples that I've seen. The machines are running really, really well. However, the gas coverage is not quite adequate. So as you can see, the weld area looks very gray. Anytime you see weld areas that look very gray, kind of crusty, a little bit cloudy, it's gonna basically mean that the weld material has overheated a little bit. And because it was so hot, the gas coverage that you had coming out of your torch was not enough to keep that safe from being oxidized. So what you're looking for is a weld something like this. These are some welds that I've done where you see a lot of gold color. Basically a gold or a straw color is gonna be the most quote unquote clean or oxide free type of welding. A little bit of color is pretty common as well. You'll have a group of people definitely online that will tell you that color is super bad. It depends what you're doing. Color is a reaction, basically a form of oxide. So technically it is an oxide. So essentially, I've talked about this in previous episodes. You want to have your stuff set up so that if you're doing anything structural or anything like that, I'm not going to speak in direct terms of code or anything like that. That's something that everybody else has to look up if you're working on a job. However, the cleanest weld you can imagine without any oxide is going to be something like a gold or a straw color or something like that. So that means there's no oxide formed on the surface. You got a nice clean setup going. What you'll tend to find is if you run too much CFH through your working pressure, so with stainless steel, I find anywhere above 25 CFH, you're gonna start to notice that your puddle is gonna be blown around slightly. So if you arc up and you get a nice clean puddle going, however, when you start to move and you notice that your puddle is wandering back and forth, essentially what I found is that you definitely could stand to turn your CFH down a little bit, because what's happening is so much gas is coming out of the gas screen or diffuser that you're using in your torch, and it's blowing directly into your welds. So you've got your heat focused in this little puddle here, yet you've got a bunch of gas pushing it around. So I definitely would encourage, if you can, run a little bit lower gas CFH than you normally think you should. You get a more stable puddle, which is really, really nice. And then you'll just need to keep an eye on the weld behind you. If your weld is starting to overly color up, or if it's definitely turning gray or anything like that, you need more gas. Kind of finding the sweet spot between those two, but basically that's a good rule of thumb of how you can tell if you've got not enough gas, where it's going to turn gray and overly oxidized and overheated and stuff like that. Or on the other end of the spectrum, where you're running too much gas out of your torch, your puddle's going to be wandering all over the place. It's going to be really annoying. So that's kind of an easy way that you can tell. All right, so let's turn on the machine here. I'm going to use my Weld 201 Pulse D. Shout out to the guys at Weld. I freaking love this machine. There we go. Just wait for the fan to turn off here. There we go. It's the nice thing about this machine is the fan turns off after a second. I did just do a review on this machine, a full out review. We do a demo and stuff like that. So go back a few episodes. I'll put the link in description, but check that episode. It was a lot of fun to break this machine down. All right, so what we're gonna do is set this up for some DC negative welding. So on this guy here, we're gonna switch it over to DC. It's already set up because our torch lead and our ground is set up so that it is gonna be running DC negative. So there's not much we're really gonna set up here. I'm on two-step. Obviously, I'm using a foot pedal. I'm just gonna control it with my foot. First thing we'll see here, I'm running about 1/2 second of pre-flow. That's cool. 0 upslope, don't want any upslope. I'm gonna turn this down. We're probably gonna run about, let's go with 90. Let's go about 90 amps. Again, we don't have upslope or downslope because we're using a foot pedal. But most importantly, we're gonna run a little bit extra on our post flow. So we're gonna run about 5 seconds of post flow. What this is going to do is that when I finish the weld, gas is going to continue to come out for 5 seconds, so that even though we're done welding, we're still going to have the gas coverage to keep our weld area nice and clean. So one way to tell if you have enough post flow or not, what tends to happen is a lot of people don't set up their machine with enough post flow. So the way you can tell that this is happening is if you finish a weld and everything you've ran is really, really nice, really, really clean, you've got good gas coverage, everything's nice and shiny like it should be. But when you finish welding, when the gas shuts off after your arc extinguishes, you get a puff where the color changes all of a sudden. So what's basically happening is that the argon shielding has been cut off before the material has finished cooling to a point where it's not going to oxidize. So that change of color real quick is basically oxide forming because all of a sudden the argon cloud has been removed. What you want to do is when you run your weld, you want to make sure that you extinguish your arc and you keep your torch covering the weld. What's happening here is the post flow is going to be running. So let's say we set it at about 5 seconds. So for 5 seconds, we want to completely cover, make sure the gas is still covering the area that we've just welded. And then when the 5 seconds cuts off, you shouldn't see that puff of color. It basically should just stay the same for the most part. It might change a little bit. However, what you're doing then is you're ensuring that you're giving it the gas coverage that the weld needs while it's hot enough to form an oxide. If you're noticing that the gas coverage is still going, and it's completely settled, there's no oxides forming, then you can start to dial your post flow back a little bit. So it'll save you a few bucks on gas to run a shorter post flow, obviously, but you want to make sure you're running enough. You're not taking all this time to set up for a really, really nice weld. You run it really, really nice, and then there's not enough gas to cover it at the end, and then it chokes down and it gets this super gross looking oxide on the surface. So make sure you run enough gas post flow to stop this from happening. All right, so enough talking. Let's get ready to run a couple beads here. So I've got some 304 stainless. This is a super common type of stainless steel. I've wire brushed it. It's super, super clean. I know it's stainless steel because I bought it and I got it sheared up for my channel here. So it is 304 stainless steel. It's nice and clean, wire brushed. I did hit it with a bit of acetone. I tend to usually hit most stuff I do in this shop with a quick wipe of acetone. It gets rid of any surface contaminant that may have been stuck on it for whatever at the shop when it got sheared or anything like that. Someone's greasy fingerprints might be all over it. So acetone or lacquer or something like that. We'll get rid of that real quick for you. Okay, so we got our machine running here. I got my clean material ready to go. It's wire brushed, clean like I said. I've got my torch all set up. Everything's done up nice and tight. I've got a clean tungsten in there. Don't let me hear from you welding with a dirty tungsten. Have a clean tungsten in there. It's gonna make it so much easier for you, especially if you're learning. What I'm gonna be using is obviously, like I said, it's a 332 tungsten setup. and I'm running a number 8 cup. I'm gonna be welding with the Edge number 8 cup. It's a glass cup, basically because I really like them, as well as for filming, you can see really well too. So I'm gonna be using the number 8 cup. So because I really emphasize that we start from the absolute basics, what we're gonna do is we're gonna run a weld using no filler rod. Now the reason that we're gonna be doing this, actually, does anybody remember what it's called when you're welding and you're not using filler rod? I'll give you a second. We talked about it a couple episodes ago. Autogenous welding. Autogenous welding means you're welding without filler rod. We're not gonna be fusing any joints or anything like that, but basically, yeah, we're just gonna skip out on the filler rod for these first couple passes, because what's gonna happen here is if you're just getting started with TIG welding, and you know what, I even encourage this for people who are just getting set up with a new machine or a new setup or something like that, eliminate filler rod for the first little bit. Reason being, hear me out here, is filler rod is an extra variable. So when you're welding and you're experiencing some kind of weird problems, the easiest thing to figure out what's going on is to eliminate variables. However, I emphasize let's work from the other side of that equation. Let's start with fewer variables. Let's just run a couple passes on some scrap material like I've got here. We're gonna make sure it's running nice and clean, nice and shiny, and then once we're confident that our torch is set up really well, our gas CFH level is set up really well, everything else with the machine is set up quite well, our post flow is still buzzing away when we're done, we'll add filler rod to the mix then. But for now, let's just start with a couple passes, just running without fill, autogenous welding or dry welding, dry arcs is what I call it sometimes with my students. But yeah, let's keep it simple, let's start with that. Okay, so we're all set up here. I'm just gonna run maybe a couple inches or something like that. We're gonna be working with about 15 to 20 degrees of travel angle. So our travel angle is gonna be leaned back about 15 to 20 degrees or so, and we're gonna be moving forward like so. Okay, we're ready to go, let's do it. So letting our post flow still cover it. You can hear the gas going, and it just cut off there. So let's take a quick look at it. So overall, the color is what we're looking for there. We don't have any dark gray or anything cloudy or anything extreme like that. It's kind of a gold straw color. Again, it's gonna look a little bit weird without filler rod, but basically what we've done is we've ensured that our torch is running nice and clean, our settings are nice and clean, everything that we need is exactly what we're looking for as far as the outcome of our weld. So we'll run a couple more of these just to make sure everything's running real nice, and then we'll start adding some filler rod. All right, so same deal. We're just gonna run a couple beads, just make sure everything's running nice and clean. I'm pretty sure this one's gonna come out well. I didn't adjust anything. I'm just gonna play with my travel angle a little bit. All right, here we go. And keep the gas on it like we talked about with the post flow. Jeez, I'm shaky today. Too much coffee this morning. It was a late night last night. Alright, I'm really happy with how this is turning out. As you can see, I added a little bit of a stepping motion to it that time. Again, we ended up with a nice gold color. It's pretty consistent to the first pass. My plate's heating up a little bit right now, so I'm going to let it cool before we start adding passes with filler. But overall, that's what we're looking for. Everything's running pretty clean. So yeah, let's let the plate cool, and then we're going to start adding some filler rod. So now that we know our weld is running pretty clean, everything's under control as far as our post flow, our gas CFH, I ended up settling at about 17 CFH. The machine, we went over all of our settings and stuff like that. But one thing I will mention, so we are going to use filler rod here. This is a 308L filler rod. So I'm going to put a chart on screen right now. So what this chart is going to tell you is basically along one column, you're going to be able to see all the different alloys for stainless. So what this means is if you're welding a stainless steel joint where you're welding 304 to another piece of 304, what you're going to do is find 304 on the left-hand column, and then what you're going to do is find 304, because that's the other piece of the equation that you're going to be welding to it. You're going to find the 304 along the top column as well, and then it'll tell you what filler rod you're going to be using for it. So this is a 308L filler rod, but you can use this chart. You can look it up on Google, it's everywhere. It will tell you exactly if you're running different types of stainless steel or whatever dissimilar types of stainless steel. It will tell you what type of filler rod is appropriate for that weld out job. So again, that's just off Google. Don't quote me on anything as far as logistics of code or anything like that. If you're welding to code or anything like that, it will give you specific types of filler rod, alloy, and stuff like that, as well as heat treatments and all kinds of other super advanced stuff we won't talk about here. But basically, that's a general rule of thumb. That's how you can get started with figuring out what type of filler rod you're going to be using. So, for example, we're using 304. We're not welding it to another piece of 304, but 304 usually calls for a 308L filler rod. That's what we got here. Okay, so again, nothing's changed. Our gas, like I said, is set. Machine's cool. Clean tungsten. Clean your tungsten if you dipped it or anything like that. But what I'm going to do is I'm going to set up and I'm going to run this weld real close to the camera here so you can see. So what you'll notice is that I'm going to start up, I'm going to arc up right here, and I'm going to let it chill out for a little bit. I'm going to add a bit of filler rod right away. So what the filler rod is going to do is it's going to get a chance to sit down and fully wed into the material. And then once I know that my puddle's wedded in fully, I'm going to start moving with it then. So here we go. So I'll give it fill right away, let the fill do its thing, move it around a little bit. Now keep the post flow on it. Okay, that turned out all right. Let's take a look. All right, so as you can see, it blued up a little bit at the start there as we moved off. So again, a little bit of color is okay for demonstration purposes here. But overall, even though there is a little bit of color to it, it's a clean weld. We're not seeing any overly oxidized area, so nothing's overly gray or really like chalky color or anything like that. Everything's nice and shiny. You can see the light reflecting in it there. One thing I do always like looking at is our heat affected zone here. So our heat affected zone is this little line you can see right there. The line remained pretty even the whole time. So anytime you're gonna see something where it's overly heated or there's not enough gas coverage to keep it cool, this heat affected zone will start out nice and slim like this, and then it'll wave out real wide like that. And what that means is basically this stuff's going to turn all gray. It's going to get overly oxidized because this entire plate is heating up too much. But what we've done here is we've added a little bit of filler rod. Filler rod does tend to cool your weld down slightly. And we've got enough gas coverage to keep it from overly heating up and spilling out towards the edges. So overall, I'm pretty happy with this. It's a nice clean weld, but basically a little bit of color for our demonstration purposes here is okay. I'm happy with it because the overall quality of the weld is nice and clean, and personally for all my art projects and stuff like that, I like a little bit of color. So you can see there's a nice little spot of purple there right at the beginning because we heated this up probably the most out of everything here. We hung out a little bit longer at the beginning, so that's why the color is a little bit darker there, and then it lightened up as we started getting rolling. All right, so because we're set up, let's just run a couple more passes and just have some fun with it. All right, let's run weld right down the middle here. So again, giving it fill right off the beginning, and this is going to help to keep your plate from overheating because you're heating up more fill than the parent material. I had a little bit of a slower start on this one, so I feel like this one's going to have more color off the bat. That one turned out pretty cool. Yeah, let's run a couple more because we're set up here. It's running real nice. All right, that's enough. Let's take a look at what we got here. Okay, let's take a look at how this all went. This plate's super hot. Okay, let's take a look at it. Overall, we see some colors, but we don't see any super gray or anything like that, so that's really good. So what we've basically been able to tell here by running a couple more beads is that our setup with our torch and our gas and everything is running really well. So like I was saying, if we were running not enough post flow or anything like that, basically what's gonna happen is you're gonna tend to see everything gray up and get really dull and chalky. However, everything here looks nice and shiny. So you can tell what we got going on is a pretty good indicator that we're on the right track with our setup. So like I was saying, the color on this last one, colors tended to drag on a little bit more. So we can definitely tell, especially by this heat affected zone bagging out a little bit more, the plate was getting really, really hot. So as the plate gets hotter, it's gonna be trickier to keep everything under control and keep it nice and like, you know, the proper colors that you should. However, we still do have actual colors. We don't have gray or dull or anything, the chalky stuff that I was talking about with overly oxidized weld. So everything looks pretty good, but you can tell our heat affected zone was starting to creep out a little bit more. So this is due to the plate being a little bit warmer than it should be for practicing. So if you're practicing, I would definitely recommend try and stick to the middle as much as possible of your plate. As you get welding towards the edge of your plate, running passes out here, it's gonna overheat really, really quickly. So you either wanna let your plate cool quite a bit, or you wanna try and keep your welds more to the middle of the plate. And that's where you're gonna have the most success with getting a nice clean weld. But overall, like I was saying, the weld hygiene, if you wanna call it, everything looked pretty good. There's no dull colors. Everything has shine to it, which is really good. Our buttons on the end are the same size as the rest of the weld. There's no pit or dimple in the middle, which meant the amount of time I used to back off the pedal was enough. If you back off the pedal too quickly, you will see a dimple in the middle here and it will sink the last part of your weld. So you want to make sure you back off a little bit slower and you'll avoid that problem. But overall, everything's wetted in nice and evenly. The colors are nice and shiny. Our heat affected zone is not too extreme. So overall, I'm pretty happy with all this. So how did you do? I want to see. Hit me up on Instagram. I'll put it on the screen right there. That's my social handle. You can hit me up, show me how you did. If you're a beginner at this and you're just getting going, I would like to see that you managed to get a nice clean arc running. I want to see pictures of, send me pictures of your torch setup. I want to see basically what you're running as far as gear. I just like talking to people. I like enjoying, especially seeing that people have learned something from my videos. It really means a lot to me. So if you got something, if you got some value from this, please share with me what kind of work you got out of it. Tell me if you got any improvements or anything like that. If you have any questions, for sure, hit me up on direct message. And most importantly, if you learned something from this and you know somebody that could benefit from learning, they're practicing themselves, share this with them. I really want people to see more of these videos. There's a ton of good how-tos on the internet, weld.com, welding tips and tricks, 5th Street Fab, Justin Voss. There's countless YouTube channels that have good information out there. So be sure to share my material direct. If you find other good how-tos, send them to me. I want to see them. Chances are I've probably already seen them. I watch a lot of this stuff. But share them with people that are learning. I'm really trying to grow my channel. So again, if you share my videos with them, I really appreciate that. What else would you like to see? If you have any ideas for the next episode on stainless steel or any other episodes kind of on general how-to questions, frequently asked questions, I like doing episodes on. Yeah, throw it in the comments below. I like hearing what people think. I will reply to you, or I'll try to at least. I won't guarantee that I will make an episode of your idea, but I'll for sure read them, and I really appreciate people that hit me up. So for the next episode, it probably won't come out for a little bit because I have a bunch of other projects I'm trying to get out on my YouTube channel as well. However, what I'm going to do is probably for my next one is I'm going to do a lap weld. We'll go over like a butt joint as well, but a lap joint TIG weld with stainless steel, something that gives a lot of people not problems, but it's a little bit trickier. You got to pay attention to a few more things. So what we'll do is we'll probably wait a few weeks and I'll get some thinner material. We'll work with a more common thickness of stainless steel that a lot of people tend to work with, which is something a little thinner. And what we'll do is we'll try and get some videos of how to on that stuff as well. But again, I really appreciate everybody that watched this episode. I really appreciate every single person that subscribes and shares my my videos. I'm having a lot of fun doing these episodes. Each one I do, I learn a little bit more about my work, my welding, and yeah, I love connecting with people. So anybody that hits me up, leaves comments, I really appreciate it. But again, I hope everyone's doing all right out there. Get in touch, say what's up, leave comments below, and yeah, I really appreciate you watching. Thanks a lot. Have a good one. Peace.